Hi, so we have now imported more images. So they are all imported. These additional ones that I added, they have quite some ice contamination and other problems. So they needed a different defect list and gain reference because they were from a different data set. And some of them are still processing, so the last 20 or so are still in the batch queue and some are here processing. I'm running 8 at the moment in parallel, and the GPUs are nicely loaded with 99% GPU utilization. That's good. Temperature and all that is still under control. And there's not too much swap in memory. So the batch queues are still running with 8 in parallel, and they all end up here in the library. And in the library they usually are imported, and they get some folder name which has a sequential number. So the last ones imported are up here, 164. And these new images have also 8K dimensions, but only 40 frames. Here are some 50 frames, and the older ones were 80 frames. And then afterwards they are cropped down to 4K. We can now sort this table here by, for example, the amount of drift, the total drift. And then these would be the movies that have the highest drift here. This one. And then I can look at this drift profile. That still looks good, and it's 25 nanometers in drift over the movie. Seems to be okay. We can sort this by jitter. Jitteriness is how straight or not straight this drift profile is, and this one has a very high jitteriness, but that's because there's almost no drift, so that would then be okay. And if you have a high jitteriness and a lot of drift, then there's something odd, like this one here. So for example, this has a jitter of 255 and drift of 14 nanometers, and that's a very suspicious drift profile. We can sort this by iciness. The ones with low iciness again is the ratio between the average intensity on the ice ring divided by the average intensity in the low resolution ranges. This would be a low iciness sample. If we go for one with a very high iciness, like this one here, that is totally devitrified sample. And then this ice ring at 3.7 angstrom resolution is very strong, the first order and the second order, and it's on average 2.7 times stronger than the low resolution intensity. There's also this iciness view, but I don't have it here right now. So if I go into this Fourier transform by double-clicking this here, I open the Fourier transform. There we see this ice ring at 3.7 angstroms. This is a Fourier transform of a recorded movie and the 2D average of that after drift correction. So we have ton rings. I can look at the ton rings by pressing C, the button C. I can do this in a moment. R would show a resolution ring that is absolutely circular, whereas C shows ton rings with astigmatism, possibly. And with the letter I can display the coordinate info. I can show you this. So if I press C, we have the ton rings, and these do not fit, so these ton rings are wrong. Well, I leave this out. This defocus determination, it completely failed on this image. And then we have the letter I, that is the resolution in angstroms down here. So this always shows the resolution of the pixel where the mouse is, the mouse coordinates and the resolution in Fourier space, and then the amplitude and phase values at that pixel position. So if I move this panel to the middle, here this ice ring is typically a 3.7 angstroms resolution here. And we still see ton rings in this ice ring. And this is the second order ice ring, that's at 2.1 angstroms or 2.2 or something. And then there's a third order ice ring here at 1.9 angstroms resolution or so, and some other ice reflection. So this is a massively devitrified sample. And these ice rings do not come back in, which shows that Fourier cropping worked. If you would been in real space, you would have other problems. So if you open this image instead by clicking onto the image, then we can see here the ice is really nicely visible all over the place. So this is a totally crystalline sample, and this ice is showing the reflections that we see in Fourier space in this ring. And such an image is difficult for image processing, so usually you would process all the images and then sort this long table by the iciness, and then I would go and say everything that has an iciness that is higher than 1.1 or so all these here, I would move them into the trash by clicking on the trash button here. And if I click here, all this will be moved into the trash button. I can also flag them, for example, red, and say these are the icy images, and leave them here for the moment. We could sort it by jitter and look for the ones that have too much jitter. So typically everything that has extreme parameters, if you have automatic data collection, you have enough data, then you would just sort these here and say this is too much jitter. The ones that have no drift, for example, total drift. So these here, if the total drift is very small, odds are it just didn't find anything to process, but these drift profiles still look okay. The ones here with 0, they have not yet processed. Deceleration should usually be a positive value. If the deceleration is negative, that means the drift started slow and then got faster and faster, probably because the ice film ruptured. And in such cases, the image may not be too useful, but these might still look reasonable. Maybe just the first one here, this is odd, this has only 10 frames, so I would also flag this as something that we don't want. The total dose should typically be what you like, and if this is too low or too high, then you could delete it. So you could just sort this table and say everything that has a dose that is really ridiculously high because something didn't work out, you could just go for all these and put them to some color or so, or move them into the trash immediately. So this is still processing. I don't want to interrupt it while processing, but usually the procedure would then be that I go for iciness and say that everything that has the iciness that is too high, I move it into the trash like this by clicking the trash button, and then it goes into the trash. And nothing is ever deleted here, it's just moved. And it's moving these folders into the trash folder. So here is some that are now in trash. This may cause a problem for the batch processing queue if an image is still processed or is still in the queue while you move it to a different location, the entire folder for that image. Then the processing queue will crash at this image, the scripts or so. But if you are sure that it's trash, then you could also move it there. The defocus is here. If the defocus is far too low, then it may not have found this, but this looks good. So here this is very low defocus, but at least it's the correct value. And if the defocus is too high, like 3 micrometer defocus, that wouldn't give us high resolution anyway. So this image, even though it says there's high resolution tone rings found, but I don't believe this image wouldn't give you decent resolution anyway. And apparently our camera had an issue in this image here. So that would also move into the trash. That's also visible in the total dose that is too low here. So this would be a trash candidate. Again, I'm recording this movie on a Macintosh with Focus running on an Ubuntu Linux computer, and I'm displaying this here with TeamViewer, and the display connection is a bit slow. So all these files here, these are previews for wherever you are in which line, and you can always look at them for the entire fields here. But now we have a real issue with the TeamViewer connection. So then you have them in the full view there, and only that. And these images here are always PNG files, which are very small and can be displayed rather fast. And if you double click on this PNG thumbnail, then you see the full MRC file in the full resolution, which can be an 8K file or 4K file. So here with this preview, one can go over this rather quickly because it's a small PNG preview. Yeah. Here's particles. So there's the numbers of particles that are found in an image. They can sort by this. So this image here has found only 20 particles, and these are images that we probably best move into the trash. Also, there's obviously a camera problem. One of the analog digital converter boards at the K2 seems to have had a hiccup. But after that it worked again. Yeah, and the ones that have too many particles, that may also be, let me sort this by too many particles. The top of the list. Yeah, here this is something else. These are not the particles we were looking for, and then it found far too many, or it's overcrowded anyway, we couldn't use it. So here again you could sort by particles and take all the images that have too many particles here and move them to the trash. And so on. So this is still processing, and for the time being I stop the processing queue here. The last ones that are still processing, they are still running. Motion core is still running a bit, and Ricardo uses this machine with FreeAlign. Okay, so and that's why it's also slowing down this computer. So in the end, when processing has finished, and I should still wait for the last two images here to finish, those are the ones that are still running here, and the batch queue should not start again, but I think it doesn't if I stopped it.